So I'm still in my pajamas, but that's okay. You can do code reviews in your pajamas just fine. In fact, I do a lot of my programming in my pajamas. So with that, I'm going to make sure that it started on YouTube. It looks like it hasn't. That's not great. Let's refresh that page. Cool. Okay, it has. It's just the joys of computers being lovely. I'm going to also just double check quickly that it started on Twitch. So, I don't trust computers anymore. Okay, looks like we're live. Okay, so today we are going to focus on some Accelerator aware PRs that have come up in Sparkland. And this will work out better if I can spell the word Accelerator. I think this is the one that I wanted to look at. And okay. I'm just bringing up the two PRs beforehand because I put them in an email to myself. Oh, I have a bug bite. I should deal with that. Okay. What day is today? It's November 15th. So this would be... oh yeah, I think this is the other one that I also wanted to look at. Okay, so these are the two PRs that I wanted to look at. So let's go ahead and start that. So switch this to live. Oh, and we're gonna update the new text. Spark PR review, Accelerator, aware, scheduling. Cool. There we go. And the title magically updates. Cool. So, so this is a stage level schedule, add base resource profile, and request classes. And this is by Tom Graves. I think he's over at NVIDIA now. Sometimes I get the company names wrong. Let's click on it. Yeah, looks like NVIDIA. And so he's, clearly, oh, good morning, Deepak. Happy Friday. Yes, I'm very excited. Actually, I'm going to go and swing by a conference in Oakland today after this PR review is done and drop off my scooter to get painted. And then, I get to say hi to some friends and maybe start my weekend a little bit early. So I hope you all have wonderful Fridays ahead of you. Oh, and it looks like the chat bot is actually working today, so that's exciting. It doesn't normally work. Anyways, back to the PR. So this adds base classes needed for stage level scheduling, and so this is important because you probably don't need Accelerator resources for all of your jobs. Right? Like if you're doing a bunch of ETL and then you're doing some machine learning, it doesn't necessarily make sense to have GPU resources for your ETL. You want them for when you're doing your machine learning. And so this is kind of cool. And it introduces some new user-facing changes. And there was a Jira, and this is if you're looking at this, you might be like, hold on, this sounds like a really big change, and you would be correct. And so it's oh, Jira is being slow today. That's unfortunate. Okay, I was gonna go and take us into Jira, but it looks like Jira is having some difficulties this morning, and that's fine. But essentially, there is a very long proposal that was voted on, and this is sort of the first step of implementing the code. And so we can see here that different people have done sort of some initial reviews. I asked for like test cases for the prototype design to see it more clearly. And the document that I asked for is unfortunately in Jira. Okay, Jira is coming up. That's lovely. So here we go. So the discovery script is in here. So I'm going to find this. No, I guess. Maybe it's in here. Okay, yeah. So let's go ahead. So discovery script. Okay. That's weird. Ah, interesting, interesting. So, okay. Yes. So this discovery script is run to determine what the resources are. And this is part of the original Accelerator aware scheduling, but it's now just in the stage level API. I'm not super sure about this, but that's okay. We can come down and see. Take a look at this. Yeah, here we go. Okay, cool. So this is interesting. So the discovery script itself isn't used by the cluster manager. It's used by the Spark Executor when it starts up to determine what accelerator addresses the container has made available. The Executor registers those back with the driver and the scheduler and uses those to assign specific tasks. Perhaps this is a little confusing because of the Executor resource request type. I can definitely document this better in the class if you have an idea. Any ideas to make that more clear in the API, let me know. Okay. So, this is fine. Yeah. Oh. Yeah, API taking bytes by default. So here, right, it's taking strings, and it's just like I don't know what's going on. Let's go down to the bottom of this discussion. Yeah, that actually sounds like a really good idea. So having a static method to just be like, hey, what's up? I want a GPU. This is probably the most common thing. Where are we at? Okay, here. Oof, this is really big. Let's go ahead and start jumping into the code. And look at the things that are added. So the Executor resource request is used in conjunction with the resource profile to programmatically specify the resources needed for an RDD that will be applied at the stage level. So essentially, if we need an accelerator, if we need a certain amount of memory, we can do that here. Yes. I don't... Okay, this is a private class. Okay. That's weird. Why is this a private class? How is this supposed to be constructed? I mean, that's okay. Huh. Yeah, this makes sense. Okay, no, this is also private. Yeah, okay. Oh, interesting. This is different from memory overhead, I think. So I think this is just a typo that we noticed. I think you mean PySpark memory. Right, unless, yeah. So, okay, minor typo doesn't really make a difference, but doesn't hurt to have this correct. Although this class is private, so I am still looking for where people would actually get this. It's the number of cores that we want in the executor. Okay, and this is the resource. This is the one where wait, what the executor? Oh, hey ZBR. I'm doing good. Today's looking pretty fun, I think. I'm confused about this add request with the executor resource request. Let me see, is this actually called anywhere? Okay, yeah, I don't see this called anywhere, any of the tests. Okay. I don't see this called anywhere, and there's no dog string. I sort of get the implicit use case, but how does this, so like this add request, executor resource request. So we have the executor resource request where that's the new class, right? Yeah. Oh no, this is an existing class, maybe. This looks like it might be an existing class. Let's go take a look. Executor resource. Nope. That's another thing. So I'm just gonna make sure that because that's weird that I can't find that. Or SRC. It's not there. I don't know how this code works. Class. Okay, here we go. This is a private class. Okay, gotcha. So this is intended to be public. So that's fine. Resource name, amount, discovery script, and vendor. Allowed executor resources does not contain. So memory overhead, PySpark cores, any resources to learn about building distributed systems. I mean, I guess it depends what kind of distributed systems you want to learn about building, Amy. Like if you want to learn about building data parallel distributed systems, if you want to learn about building like distributed programming languages, Heather Miller has an amazing talk about sort of the history of those. I don't know, what kind of distributed systems you want to build. Yeah, okay, so this, so far, right now, doesn't have GPU inside of it. So, the Java doc, the Scala doc references GPU, but we don't seem to have it here. That's a future add, right? I just want to make sure that I'm not missing something, right? So, okay, so where do we get this executor requests from? So wait, is executor requests going to become a public API? I guess that's really should be my question. Okay, so this is intended to become public. So memory overhead, PySpark memory, cores, and arbitrary resource. Okay. And wait, what? So this is Executor resource requests. Executor resource request. Okay. And we do intend to make distributed systems. Oh, okay. So more like distributed databases. So I think one of my coworkers made a database internals book that could be really interesting to look at. He does a lot of work on Cassandra, so I think that could be an interesting thing to look at. I mean, there's some sort of classic papers from Google. I don't necessarily like them as much, but yeah, maybe the database internals book, if what you want to build is distributed system to do transactions. So this is the resource and request. Okay. Yeah. Okay. This seems okay, I guess. Yeah, that's fine. I like these. I want to see the GPU one in here at some point too. Oh, how do you test the systems without a cluster? Okay, that's different. Yeah, okay, cool. So those are two things. So let's go ahead. So database internals O'Reilly. Is this the one? Could see this. Yeah, probably this is the one. O'Reilly database internals. Alex Petrov. For the testing without a cluster, I mean, that's really hard. Generally speaking, at some point, you need a cluster. Thankfully, like things like microK8s make it relatively easy to simulate a cluster. Spark itself has its own cluster simulation, but like microK8s is probably a good option for doing those sort of tests. If you want to test failure, just in GitHub Aether, like this is probably a really interesting thing. A framework for distributed system verification with fault injection. It's by a really great person, but it also does a really good job of finding sort of errors in your distributed databases. Yeah. Anyways, I think those could be interesting. Okay. Where was I? Back here. Yeah, I got this resource, I guess. Okay. So, optional vendor. Yeah, I mean, I get that. This API is like a little, but whatever. We want to be Java friendly. So here's our resource profile. Do we want to? Executor resource requests. Okay. Okay, task resource request. I'm not, this is used in conjunction with a resource profile to programmatically specify the resources needed for an RDD that will be applied at the stage level. I don't know if I understand this one. Oh. Hi, Vishal. I'm good. I'm pretty optimistic about today. How about you? How you doing? So I'm not... This check seems like in kind of a random place. Let's go ahead and see how this thing is called. Gotcha. Yeah. I don't really like... I feel like this is an odd way of doing this. Could we have a double amount and an int as different signatures? Someone scaling up the percentage of a resource. Being able to specify more than 50% of a resource. This seems weird. Yeah, I think that's a fair comment. In the API. Resource GPU resource. Where is this GPU? Interesting. I'm confused about the interplay. So I'm confused about the interplay there. Since I thought so. Okay. I thought the allowed resources didn't yet include. I don't want to leave a second comment. I want to. How do I link to this? I don't know. God damn it. Whatever. I'll just. This is I thought executor resource request. Okay, now I have a lot of cases where I'm saying this. Okay, so I'm confused, which is not a particularly abnormal thing when I'm reviewing a really big chunk of code. Since looking at the code, I don't see GPU or FPGA listed as allowed resources yet. So if we go here inside of executor resource requests.scala, when we pass this in, it makes an executor resource request. So when we make the executor resource request, it should throw a new illegal argument exception. If allowed executor resources does not contain resource name, and resource name does not start with resource dot. What the fuck is resource dot? Okay. Gotcha. Okay. That's fine then. I think this makes more sense to me. So then let's go ahead, delete this comment. That's fine. Maybe just for the Spark internal resources and everything. Resource type is allowed. And that's just like, hey, what's up? I got confused reading this code. Maybe let's add a comment so the next person reading this code doesn't also get confused in the same way. So that's cool. Yeah, same thing. What does okay, fraction. Yeah. Yeah, so we see here in the initial design they were using ints. I don't know. And it feels like we should just have this be an option or an either type. Okay, so that makes sense. Yeah, I want to discard that change. My script, my FPGA script. Okay. So I think this looks kind of reasonable. It doesn't make big changes yet, and people have agreed to sort of the general direction of the change in the design doc. Although this is definitely a little bit different. Oh, yeah. Yes, okay. This looks not unreasonable. The discovery script. From looking at the design, I think the discovery script seems to need to be resident on the machines already, on the executors already. Maybe call that out since another option would have been to broadcast the discovery script. Okay, I mean, I think that's, like, from a code point of view, those are sort of the comments that I have. And so I guess the other thing here is there's like not a lot in about the discovery script in here. Yeah. Oh, maybe it's all camel cased. I could see that. Let's go take a look at Spark 24615. Maybe that's what I meant. Okay, there's probably, oh, it's a PDF. Okay. Discovery. discovery. I don't see discovery script. I don't see this. Oh god, why is my computer beeping at me? Oh, cool. Yeah. Okay. Yeah. So I think, yeah, so there isn't a lot about the discovery scripts in 27495 or whichever this one is. What is this one? Or 24615. But I get that we've made a decision. I still think we should clarify it a bit more. And I think you've done this. So I'm gonna can I do there's normally a resolve button. I guess there's only the resolve button on the PR author's side. So essentially, like, this comment's fine to resolve. Oh yeah, they're running on yarn 1. I mean, this is okay. Let's select GPU. Yep. That's fine. Spark. Yeah. Okay. That's more or less what we would expect here. Okay, cool. I think this looks reasonable to me. For the most part, I have some relatively minor feedback. Yeah. Matching resources to Executor. Saying a resource profile means new executors with the resource. Oh god. Okay, yeah. So let's go ahead. Some minor points about the API which I found a bit confusing when reading. Yes. Mostly docs, maybe small code change for fractional resources. Also, how do we reason about fractional resources here? I didn't see a lot about that, but maybe I missed it. So I think yeah. I think we should make the eventual implementation clear of how we use this. Yeah, no. So I think this is okay. Although I may want to release the executor as each one is using an additional 1 GB. Yeah, I mean, this is an interesting question of, I think, like in dynamic allocation, the case where we need to spin up new resources is easier to reason about, and figuring out what we want to do around deallocation is a lot harder. So I think it would be okay to start with the case of focusing on how we spin up new resources, e.g. adding GPU nodes when needed, and hoping the job finishes shortly after, and then we can explore spinning down, adding GPU resources after, especially given the current challenges of deallocation in Spark. So this is essentially my take, saying that, like, yeah, certainly we do have the situation where we might need 9 gigs memory, then we only need 8. And yeah, that could be a lot of memory conceivably. However, you know, we could focus on the simpler case where we have a linear scale up and then our job finishes. And that's true, that's not all jobs, but it's better to support scale up first, because right now people are having to request these resources for their entire job, and this way at least you might not need them for the entire job, and we can deal with scale down later. And part of that is I have my own work around scale down, because scale down is not perfectly implemented in Spark. So I think trying to solve scale down in the scope of this PR might be a little bit hard. Comment-wise, we don't actually have all that many comments coming out of this, despite taking like 40 minutes to review it. A lot of that time was just figuring out what the hell's going on. And that's pretty normal for bigger changes. And so, like, minor notes around sort of comments and documentation changes, and one sort of API change where it's like, hey, I don't think that doing this as a double is a great solution, because we sort of introduced this discontinuity where you can ask for up to half of a resource fractionally, and anything above that doesn't work fractionally. And I know there are places in the Spark API where we do that. We normally do it in the range of 0 to 1 though, rather than 0.5. Actually, yeah, let me clarify that now, actually, that we're talking it through. If we are doing this fractionally, if we do want to do this fractionally, I'd say maybe keep it as a fraction up to 0.9, up to, but not including 1. If we do want to do this with a single type / function, this is like I mean, this is just a design suggestion. I would say it seems reasonable that someone might want to request 3/4 of the memory available to do their deep learning thing. For example, I'm not sure what half a GPU means. To be fair, like I don't think we can really do that very reasonably. But actually, yeah, maybe that's a question that we can ask. Yeah. Also, what would we do in the case a user asks for half a GPU? Yeah, and so it's just like, I don't, like, if we're making an API, it's better if it makes sense, or at least, you know, we fail quickly when users ask us to do things that don't make sense. Other ones are just comments, so that's fine. We'll go ahead and leave a comment. I like this PR. It's coming along pretty well. It definitely, you know, it has 64 comments. It's not a, yeah. So it could be. So half a GPU could be half of the GPUs available. That's a good point. Would we, sorry. Half of the GPUs available. In the situation, thinking about the situation where the node has 1 GPU and we ask for 0.5. Of it. But maybe the nodes will all have more than that. Yeah. So anyways, that's a good catch, CBR. It could mean half the cores of the GPU, but I don't think you can really do half the cores on a GPU easily, like with any safety. I could be wrong here. Like with CPU cores, yeah, but with GPU cores, I didn't think I could. Okay, so that's some design docs that we looked at. More design docs. What was this one? Okay, this one was around failures and blacklisting. It's not related to the Accelerator aware scheduling, but I did promise I would take a look at it on Friday, so we'll do this one relatively quickly. Executor pods allocator does not limit the number of executor errors or deletions, which may cause executor restart continuously without application failure. Add XMSE after Spark submit, which can make the executor a simple example for this. Okay. Cool. Rockin'. So that looks reasonable enough. Yeah. Yeah, I don't know how half a core would work for GPUs. So let's see here. Yeah. So this is an int.conf. I think we could use a check value here. Use a check value here. Okay, start review. Seems good. Executor ID counter? I don't... Okay. Exit max executor failures is hard-coded to 11? What? What? I don't get this. Okay. Maximum executor failures is conf get Kubernetes max executor failures, get or else. Maybe specify what the default is. Review comment. Okay. Math max if total expected executors .get is greater than int max value divided by 2, return int max value. Okay, reasonable. Otherwise, allow each executor to fail twice. Sure. Num-failed executors. What? Not. I don't. I don't know about this necessarily being the best way to track the number of failed executors. Yeah, I don't feel great about this. In dynamic allocation, it seems like if we scaled up and then down a few times, this would give us an incorrect reading. Or is that taken care of elsewhere? One of the lovely things about code reviews is I can just be like, I don't know, please tell me. And if I'm doing it myself, I have to go figure it out. Yeah, it's probably a fine unit test. Let's go back, take a look at the other comments in the conversation because there's 30 of them. So that's yeah. Yeah. So yeah. So this is actually a Jira number that I've been meaning to look for that I actually want to follow. Oh, it's okay. So let's log in here. It's probably with my id.apache.org password. I don't know why I have so many different passwords on the Apache domain for the same user account. But that's life. I definitely want to follow this. Because this is a thing that has been me in the past where our blacklisting isn't super great. Let's leave it a comment. Request changes. Seems weird. Oh. No, I mean request changes are legit because we are actually requesting some changes. I'm a bit uncertain about how we're tracking the number of failed executors and how it might interplay with dynamic application. Also, some minor comments around clarifying / improving. Thanks for working on this. Cool. Rockin'. So there we go. That's good. It's almost 10 a.m. so let's go ahead. Seems like a good time to wrap up. I should get back and do sort of more my normal work. Also probably put on makeup and like look like a human being. Thanks everyone for joining me. Oof, these lights are rough. Alexa, dim bedroom to 30%. Okay, that's a little better. The soft lighting, 40% is a bit much. But yeah, thanks for joining me. This is a little bit different. We spent most of our time focused on one PR, a little bit of time following up on a second one that I just promised that I'd take a look at. So thanks everyone for joining me, and thanks everyone for chatting today. It's always more fun with folks to talk to. I hope you all have a wonderful weekend ahead of you, and I'm gonna go and get ready for work and drop off my scooter and go to the Scale by the Bay conference in San Francisco. So yeah, hope everything goes well. I don't see any last comments, although the YouTube delay is sometimes a little bit long, but we'll just wrap it up. Bye, y'all. Oh yeah, and I'll remember to like and subscribe and click the bell, I think. I don't know, whatever. But if this is your kind of thing, yeah, definitely like and subscribe on the channel. Have a nice day, y'all.